Mekkhala pivots toward land. Super typhoon's sudden turn triggers mass evacuations. Just hearing that feels unreal, but this is exactly what is unfolding right now across the Western Pacific. Families who went to sleep thinking the storm would stay offshore are waking up to sirens, evacuation alerts, and emergency messages telling them to leave everything behind and run. On the northern coast of Luzon, in Taiwan, and across the southern islands of Japan, people are watching satellite images of a swirling monster only a few hundred kilometers away, its winds roaring at speeds that can rip roofs off houses and turn debris into weapons. This is Super Typhoon Mekkhala, the most powerful storm system on Earth right now, and it is starting to make a big, slow, and terrifying turn. For days, it looked like it would stay safely over open water, only brushing the Philippines and Taiwan with outer rain bands and strong gusts. But now, the core of the storm is wobbling, the cloud structure is shifting, and the atmosphere around it is tugging Mekkhala into a new direction that puts millions of people in its path. Evacuation centers are opening, flights are being canceled, coastal villages are packing up, and emergency teams are moving into what they call action mode. This is not just a routine typhoon forecast. This is a high-stakes pivot where every small shift in the track means the difference between glancing blows and direct hits. As the storm slows down and curls, it spends more time dangerously close to land, whipping the northern Philippines with rain, feeding the southwest monsoon, and threatening to bring destructive winds and heavy flooding to Taiwan and the southern islands of Japan. At the same time, another tropical system in the region is trying to organize, raising fears that two storms might interact in complex ways, even though meteorologists explain that one will eventually dominate and absorb the other. People are left staring at tracking maps and color-coded wind charts, trying to understand what it means when a super typhoon starts to stall and then pivot. How did Mekkhala get this strong? Why is it turning now? And what will happen to the communities directly in its new path? This is the story of Super Typhoon Mekkhala's sudden turn, the science behind its big pivot, and the human drama of mass evacuations racing against a storm that seems determined to test every level of preparedness in the region. What happens when the most powerful storm on the planet decides, at the last moment, to lean closer toward land? Super Typhoon Mekkhala did not begin as a monster. It started as a simple disturbance far out over the warm waters of the Pacific. One more swirl of clouds in a region that produces some of the strongest tropical cyclones on Earth almost every year. At first, it was just a cluster of thunderstorms, a tropical depression moving between the islands of Micronesia, with bands of rain and pockets of gusty winds that seemed more annoying than truly dangerous. But the environment around it was almost perfect for rapid intensification. Sea surface temperatures were well above the seasonal average, providing an oceanic fuel supply that allowed the system to pull more and more energy from the water below. As Mekkhala moved into the Philippine Sea, wind shear, those changes in wind speed and direction with height that can tear storms apart, was surprisingly weak. Instead of being ripped to shreds, the storm was allowed to organize, stack vertically, and tighten its circulation. In satellite imagery, meteorologists began to see deeper white and even purple shades around the center, signs of incredibly tall cloud tops and intense convection bursting around a developing eye. The pressure in the core dropped quickly, and the winds roared higher, crossing thresholds that upgraded the system from a tropical storm to a typhoon, and then, stunningly fast, to a super typhoon. Within a short span of time, Mekkhala's sustained winds surged to roughly 240 kilometers per hour, with gusts reaching 175 miles per hour. That kind of power is not just about wind. It is about what the wind can do to structures, trees, and coastlines. At those speeds, roofs are peeled away, poorly built homes can be shredded, and flying debris becomes deadly. Meteorologists watching the storm noted that it had rapidly intensified because there wasn't really anything stopping it. The waters were hot, the atmosphere was supportive, and the storm was free to evolve into one of the most intense systems of the season. As this happened, the geography around Mekkhala began to matter more and more. West of the storm sat Luzon, the largest island of the Philippines, home to tens of millions of people and critical infrastructure including Manila, the national capital region. North and northwest, Taiwan and the southern islands of Japan formed a chain of land that could be struck if the storm bent its path in their direction. For days, the main hope was that Mekkhala would track just far enough east to spare land from its catastrophic core while still sending outer rain bands and strong winds across the region. But the atmosphere had other plans. When meteorologists talk about a storm feeling something, they are describing how a cyclone responds to larger-scale features around it. High-pressure systems, troughs, and jet streaks that guided along invisible rails in the sky. In Mekkhala's case, there was something to the north that mattered, developing shear and steering currents that were about to tug the storm, change its angle, and eventually force it to pivot. As they watched, they noticed that the north side of the storm showed fewer intense cloud tops than the south, meaning much of the cloud cover and strong convection was now skewing toward the southern flank. This asymmetry suggested that the storm was starting to react to outside forces and prepare for a turn. That turn did not happen instantly. Super typhoons are enormous, and when they change direction, they often do it slowly, wobbling like a spinning top that starts to drift. Mekkhala's center began jogging a little more toward the west-northwest, hinting at a gradual curve rather than a straight run. At the same time, the storm started to slow down. This was the worst possible combination for nearby land. A powerful system hovering near the coast, moving slowly, staying close enough for its outer bands and enhanced monsoon flow to lash the Philippines with repeated waves of rain and wind. From a forecast perspective, this slowing and wobbling made the situation more complex. The storm's intensity was still very high, but the gradual increase in wind shear and interaction with mid-latitude features was expected to weaken it later. Yet, starting from such a high intensity meant that even weakening would leave Mekkhala as a dangerous typhoon when it approached the southern islands of Japan. The forecast track began to show the storm curling, with its core remaining just east of Luzon, then sliding closer to Taiwan, and ultimately pushing across Okinawa and the Ryukyu chain before getting entangled with a frontal boundary near Honshu. In the Philippines, this pivot triggered a wave of anxiety. Even if the center was expected to stay offshore, the outer rain bands and the enhancement of the southwest monsoon meant more rain for regions like the Visayas and western parts of Luzon. Those areas are already vulnerable to flooding and landslides, and every additional millimeter of rainfall on saturated slopes can push communities closer to disaster. Meteorologists warned that while the core might remain to the east, the system would still influence the country strongly. People in Metro Manila and nearby provinces watched as cloud shields expanded and rain chances rose, knowing that they were facing a storm that was close enough to matter in every forecast. As the storm's pivot became clearer, planners across the region shifted into action mode. In the southern islands of Japan, where Mekkhala was now projected to move almost directly across, authorities began preparing for typhoon impacts later in the week and into the weekend. The forecast showed winds near 137 kilometers per hour as the storm approached, gradually weakening to around 120 kilometers per hour as it moved along the island chain. That is still roughly 75 miles per hour, strong enough to cause damage, especially in exposed coastal communities. For these islands, the message was simple. This would not arrive as a super typhoon, but it would still be a significant storm with heavy rain, strong gusts, and the potential for flooding and wind damage. Emergency managers do not wait for landfall to act. They look at the track, the timing, and the intensity forecasts, then start moving people and resources before the storm can trap anyone. With Mekkhala, The forecast track showed the system curling slowly, staying just off the east coast of Luzon for a couple of days, then crossing near Okinawa as a strong typhoon before racing north toward Kyushu, Shikoku, and Honshu. This gave officials a narrow window to organize evacuation routes, secure coastal shelters, and warn residents who might not yet grasp how serious the situation had become. On the northern coast of Luzon, where the outer rain bands were already brushing the shore, some communities began early evacuations from flood-prone areas. Past storms have taught painful lessons about waiting too long. When rivers rise suddenly, or storm surge pushes inland faster than expected, roads can disappear beneath water, and evacuation becomes almost impossible. Authorities urged people living near coastlines, rivers, and landslide-prone hillsides to move to higher ground or designated centers, even though the core was forecast to remain offshore. It was better to move early than to gamble on last-minute rescues. In Taiwan, the message was similar, but more focused on the storm's close approach without direct landfall. The forecast suggested that Mekkhala would pass very close to the island, with the core remaining over water, but close enough to bring strong winds, intense rain bands, and dangerous seas. Coastal communities prepared for heavy surf, possible coastal flooding, and landslides in mountain regions where rain can run off quickly and destabilize slopes. Once again, the slow pivot meant that the island would experience a prolonged period of rough weather rather than a quick strike. For the southern islands of Japan, the language shifted from caution to direct action. Meteorologists describe the region as being in action mode, a phrase that captures the urgency of making real preparations rather than just watching the forecast. In Okinawa and Naha, officials urged residents to secure loose objects, prepare emergency kits, and consider whether they needed to move away from low-lying coastal areas. Schools and businesses reviewed plans to close temporarily, and hospitals checked backup generators and supplies in case power outages occurred during the peak of the storm. Complicating matters was the presence of another system, Tropical Depression 8, located behind Mekkhala near the northern Mariana Islands and Guam. At first glance, it was easy for the public to imagine these two systems combining into a single, even more dangerous storm. Meteorologists took time to explain that this is not how tropical cyclones behave. Instead of merging into one giant storm, usually one system dominates, absorbing the other or weakening it through wind shear and environmental competition. In this case, Mekkhala was clearly the stronger system, effectively controlling the atmosphere around it. Tropical Depression 8 sent a blob of heavy rain towards Saipan and Tinian, bringing gusty winds of 50 to 70 kilometers per hour and periods of poor visibility. Some of that rain clipped Rota and even parts of Guam, but it was not organized into a strong typhoon. Forecast models suggested that as this depression entered the Philippine Sea and turned north, it would not get as far west as Mekkhala and would eventually weaken, possibly becoming a tropical storm before being absorbed into the larger-scale frontal systems affecting Japan. Still, for people already anxious about Mekkhala, seeing another swirl of clouds on radar and satellite images added to the sense of unease. While meteorologists focused on track lines and wind speeds, ordinary people watched the sky and listened to the rain. In the Philippines, especially across western Visayas and parts of Luzon, the enhanced southwest monsoon brought heavier showers and thunderstorms, sometimes arriving in waves that made streets flood and rivers swell. Residents shared videos of sudden downpours, gusty winds, and dark cloud shields that seemed to hang over their communities longer than usual. Even if the actual eye never came ashore, the system's presence to the north changed daily life, turning routine commutes into careful journeys through wet and slippery roads. Farmers worried about crops standing in fields already soaked by earlier rains. Fishermen watched the growing waves and stayed in port, losing income but choosing safety over risk. Parents monitored school announcements, wondering if classes would be suspended, while emergency responders checked drainage systems and prepared rescue equipment just in case flash floods broke out in vulnerable barangays. Everyone knew that the storm's pivot meant it would hover near the coast longer, increasing the chance that small changes in the track could suddenly bring more intense impacts. Farther north, in Japan, the focus shifted to the timing of landfall. Forecast maps showed that as Mekkhala approached Okinawa, it might weaken slightly due to increasing wind shear, but then tighten up again as it became entangled with a mid-latitude front. This interaction can sometimes boost rain and spin in parts of the circulation, leading to pockets of stronger winds and heavier rainfall, even as the overall storm transitions. For residents on the southern and eastern coasts of Kyushu and Shikoku, this meant preparing for periods of intense gusts, potentially reaching 90 to 95 miles per hour in some areas, as the storm moved north over the weekend. As the system lifted toward Honshu and areas around Tokyo, the forecast emphasized tropical storm impacts rather than full typhoon strength. This still included heavy rain, strong gusts, and the risk of localized flooding, especially in urban areas where drainage can be overwhelmed by sudden downpours. Transportation networks, already sensitive to strong winds and heavy rain, faced the possibility of delays and closures as the storm's remnants moved through. Throughout all of this, one theme remained constant: the importance of accurate, calm communication. Meteorologists emphasized that Mekkhala was not coming into Luzon or Taiwan directly, even though it would be very close. They explained that while the storm's core would stay over water initially, the outer influences could still be dangerous, and that preparation should not be delayed, simply because the center might remain offshore. They reminded people that every storm has unique behavior, and this one was already showing signs of slowing, wobbling, and reacting to shear and frontal boundaries in ways that had to be monitored hour by hour. For many viewers, hearing phrases like, "I appreciate your trust" from forecasters mattered more than technical details. In high-anxiety situations, where maps show a powerful storm seemingly headed straight at a region, reassurance that the forecast is based on decades of experience and careful analysis can help communities stay focused and avoid panic. The emphasis on sharing correct information with friends, family, and community groups reflects an understanding that in a connected world, rumors can spread faster than storms, and clarity is a form of protection. As Mekkhala continues its pivot toward land, the story is still being written in real time. The storm has already reached its peak intensity, and forecasters are watching closely as wind shear begins to chip away at its structure. Yet even weakened, it remains powerful enough to bring typhoon-force gusts, dangerous seas, and flooding rains to Japan's southern islands, and strong tropical storm impacts farther north. In the Philippines and Taiwan, the enhanced monsoon, outer bands, and close-pass winds remain concerns, especially for low-lying and mountainous areas that are sensitive to heavy rainfall. This is not a simple landfall scenario where a storm charges straight at one coastline and then fades away. Mekkhala's path is a long, curving journey, hovering east of Luzon, skirting Taiwan, blasting through the Ryukyu Islands, and then merging into larger weather patterns over mainland Japan. Along the way, every shift in its track and every change in its intensity shape the lives of millions of people who must decide when to evacuate, when to shelter in place, and how to protect what matters most. In the end, what makes this storm so unsettling is not just its strength, but its timing and behavior. The most powerful storm system on Earth, deciding to slow down and pivot near land, turns a forecast into a prolonged test of patience, preparation, and resilience. Families in coastal villages, residents in dense cities, and workers on critical infrastructure all find themselves linked by the same swirling mass of clouds and wind, waiting to see exactly where Mekkhala will go next. As evacuations continue and emergency plans unfold, the lesson of Mekkhala's big turn is clear. We cannot control where the storm goes, but we can control how we prepare, how we respond, and how we support one another when the winds rise and the rain begins to fall. When the most powerful storm on the planet pivots toward land, it forces us to ask not just what the atmosphere will do, but what we will do in return. And as this super typhoon moves, slowly and relentlessly, across the maps and into the headlines, one question hangs over every community watching the radar. Will our preparations be enough when Mekkala's turn becomes tomorrow's reality? But to really understand why this pivot feels so dangerous, we need to look at how storms like Mekkhala expose the weakest points in our systems, not just our coastlines. Every time a super typhoon draws close, it tests power grids, communication networks, hospitals, and evacuation routes in ways that no ordinary day ever does. When roads flood, when cell towers go down, when electricity fails in the middle of the night, it becomes clear very quickly which communities had solid plans and which ones were hoping the storm would simply stay away. Think about the islands and coastal towns along Mekkala's projected path. Some of them are used to strong storms, with reinforced buildings, regular drills, and clearly marked evacuation centers. Others have grown rapidly in recent years, with new homes built in areas that were never designed to withstand typhoon-force winds or serious flooding. When a super typhoon slows down and pivots closer, the difference between those two realities becomes painfully visible. Well-prepared communities may still suffer damage, but they can move people out of danger faster, communicate more clearly, and start recovery sooner. Less prepared areas are left scrambling, trying to move families, elders, and children through rising water or over unstable ground at the last possible moment. Mekkala's evolution also highlights how much we now rely on advanced forecasting tools and global coordination. The track you see on your screen is not just one computer model. It is the product of many models, satellite data, and constant cross-checks by meteorologists watching every wobble of the eye. When the storm began showing signs of turning, those changes were picked up in the cloud structure, in the distribution of rain bands, and in shifts in the steering currents around it. That allowed forecasters to update warnings, adjust timing, and give communities a clearer picture of what to expect. Without those tools, the sudden pivot would have been far more shocking, leaving people with far less time to react. At the same time, the situation reminds us that even the best forecasts cannot remove uncertainty. A super typhoon that is only a few hundred kilometers offshore can shift just a little and suddenly bring far stronger winds to areas that thought they might escape with mostly rain. That is why meteorologists stress ranges and probabilities instead of absolute guarantees. They know that storms like Mekkhala are sensitive to subtle changes in shear, temperature, and larger-scale weather patterns that are still hard to predict perfectly. For people on the ground, this means that taking action early, before every detail is perfectly clear, is often the safest choice. There is also a deeper emotional side to all of this. In the Philippines, Taiwan, and Japan, many families have lived through other storms before, some of them catastrophic. When a new super typhoon appears on the map, those memories come back fast. Past floods, long blackouts, damaged homes, and nights spent in crowded evacuation centers, listening to the wind howl outside. Mekkala's pivot toward land does not just move lines on a forecast chart. It pulls up fear and stress that have been carried silently since the last major storm. Hearing that it is not coming in, but it will be very close, is both a relief and a new source of tension. People hope the Corps really will stay offshore, but they also know that hope alone is not a plan. And that is where community makes the biggest difference. Behind every evacuation order are volunteers opening centers, local leaders checking on vulnerable neighbors, and families making room for relatives who need a safer place to stay. In coastal barangays, in mountain towns, and on small islands, people often rely on each other more than anything else when the winds rise and the rain begins. Sharing accurate information, helping someone pack quickly, lending a vehicle for transport, or just calming a frightened child. these small actions add up to real resilience. Mekkhala may be one of the most powerful storms on Earth right now, but it cannot erase that kind of strength. As the storm continues its slow turn, and the days ahead bring more rain, more wind, and more updates, one thing remains constant. Preparedness is never wasted. If Mekkhala bends a little farther away, and some areas are spared the worst, the work of evacuating, securing homes, and planning responses will still have value. It will serve as practice, as proof that communities can mobilize when they need to, and as a reminder that early action saves lives even when the final impacts are less severe than feared. And if the storm's pivot brings it closer than expected, those same preparations may become the line between damage and disaster. In a world where powerful storms like Mekkhala can intensify quickly and change direction late in their journey, the question is no longer whether we will face these tests, but how ready we will be when the next pivot happens. The maps will keep updating, the satellite loops will keep spinning, and the forecasts will keep refining the details. But the real story will always be written on the ground by the choices people make, the care they show for one another, and the courage they find when the wind starts to rise.